Hi everyone, in this video I will be explaining Gauss Seidel method load flow analysis problem. Let us consider a problem to find the solution. In this slide I will be showing you the problem. Using Gauss Seidel load flow method, we have to compute at the end of second iteration. We have to find the two things. One is voltage at buses 2 and 3 and real and reactive powers at the slack bus. So, for this they have given the one line diagram. So, here we have 3 bus system, bus 1, bus 2, bus 3 they have marked here. So, we have 3 bus system. Between 3 buses it is connected 3 transmission lines, and the line data is clearly given, the buses P and Q. So, where it is connected the line, and line impedance is given, and also the total offline charging admittance is also given. So, this is about the line data, and the system data is also given, that is the input data. So, bus at each bus what type of bus each bus is, and what are all the details are required, it is given. So, bus 1 is a slack bus, and P and Q is unspecified there, it is put dash here, and voltage, magnitude and angle are given. And the second and third bus both are of load bus only load is connected. If you consider the first bus, we have a generator. So, the second and third bus are PQ buses, P and Q values are given at the bus. So, with these data it is required to find the voltage at the buses 2 and 3 and real and reactive power which are unknown at the slack bus. First of solution requires, the first step is to find the bus admittance matrix by using inspection method using the line data. So, this Y bus matrix, the Y bus matrix you can find, Y bus matrix is the order of the matrix is equal to the number of buses. Here the number of buses are 3, therefore it is 3 cross 3. So, the elements of the Y bus it is written here. So, this is the Y bus matrix. In this Y bus matrix diagonal elements Y11, Y22, Y33 and off diagonal elements are these. Actually, this, as you all know, the Y bus is a symmetric matrix. So, you have to find the diagonal and off diagonal elements, and the remaining elements you can easily copy from the other rows. So, only a diagonal and one off diagonal elements need to find. So, for that it is clearly given in the problem, the line details, line impedance and admittance are given. So, this already it is told in my video. So, briefly I am telling here. So, here one line diagram is given. So, here for the first step you have to find the Y bus. So, the elements is like this, you can find Y11 is nothing but sum of all the elements connected to bus 1. See, bus 1 is connected to 2 elements. So, you have to consider the line admittance Y12 plus Y13 plus, actually this value they are given. So, that is Y12 dash by 2 plus Y13 dash by 2, this is the formula. So, Y12 is nothing but they are given Z12, you have to take that J.4 plus 1 divided by J13, 13 is given, this value is given. So, J.4 plus and Y12 dash, that is 0.1 plus J.1, 13 here 0.1 half of that. Like this let us we should consider and find the Y11. Similarly, Y22 in the same lines you can find, and Y33 also, Y33 you can find in the same lines. So, the answer for this Y11 you will get after the calculation you will get minus J4.8, and Y22 you will get minus J7.35, please do the calculations on your own, you will get the answer 7.35. So these are the answers for y11, y22, y33, the diagonal elements of y bus matrix. So the off diagonal elements you can find like this: y12 is nothing but negative of the line admittance connected between the buses. So that means y12 that is negative, that is 1 divided by z12. So minus of 1 divided by z12 is 0.4. So if you simplify, you will get this answer for y bus. So the y bus matrix, after the simplification as per the method I explained, you will get minus 4.8, minus 7.35 j, so minus j 7.35, and here j 2.5, j 2.5, j 5. So these first row elements are same as first column elements. You can copy the other elements, and similarly second row elements are same as second column elements. So here you are required to find only the diagonal elements and one side of the off diagonal elements, so that job completes. For all the load flow calculations, one has to find the bus admittance matrix. This bus admittance matrix is very helpful in calculation of voltages, real power and current calculations. Once you find the value of the admittance, so it is required to find the voltage. So voltage at the second bus, suppose here the system they have given like this, here the system they have given, so that is I will write once again the system given. This is what the system given. At first bus we have generator, and second and third bus we have loads. So if you use this information, you can write V2. V2 at the end of first iteration is equal to 1 divided by y22, 1 divided by y22 into S2 conjugate divided by V2 k conjugate, k is 0, minus, so here V2 you are finding here, so 2 1 y21 V1 slack bus minus y23 V3 0. So this is the formula we have to use for finding the voltage at the second bus. So here y22 is known, y22 value is known here minus j 7.35, and then S2 is nothing but P2 minus jQ2. So S2 conjugate, by S2 means P2 plus jQ2. If you take conjugate, you will get P2 minus jQ2. So V2 value is not given, therefore 1 at an angle of 0, take conjugate, minus y21 value is known, that is j 2.5. V1 value is given from the problem, the value is 1.03 given, it is here, value is given 1.03, we have to consider, and P2 value is given, Q2 value is given. We have to consider this minus 0.4 and minus 0.3 in this calculation. So here we have to use that, that is here this answer is minus 0.4 minus 0.4 minus 0.4 minus j 0.3. So this you have to consider here. Next minus y23, it is given y23 j5, and then the value of V2 is V3 is not known. So bus 1 voltage is given 1.03, but here V2 bus voltage is not given. We have to initially flash start, that is 1 at an angle of 0, and here V3, this is V1, this is V2, and V3 value is also not given. We have to assume this as 1 at an angle of 0. So you have to substitute all these, you have to calculate all these, and you will get the final answer for V2. V2 is, you will get 1.0946 10 angle of minus 2.9 per unit. So all the values of voltages in per unit, it should be around 1. Similarly, one can find the voltage at the third bus. So for that, this is 1 divided by Y33 P3 minus JQ3 formula, V3 conjugate V30 conjugate minus Y. See here how many elements are connected by third bus. See, the third bus is connected with 2 elements, that is Y2, Y3, 2. Between 3 and 2 we have a transmission line, and between 3 and 1 we have a transmission line. So those things you have to consider here. Y31 V1 minus Y32 V2 of first. In a Gauss Seidel method, this is very important to consider the latest calculated values. So V2 of 0 you should not consider, V2 of 1, because V2 of 1 we have the value. So this substitution, Y33 we know, Y33 value is already calculated, minus J7.35, and P3 and Q3 value they have given, you have to consider 0.5 minus 0.4 J0.4 divided by, this is 1, make it bracket, V3 of 0 1, if you take conjugate remains same, minus Y31 it is given 2.5, V1 1.03 minus Y32 is J5, into V2, previously calculated value of voltage at the second bus we have to consider 1.0946 at an angle of minus 2.9 per unit. So this no need to write per unit here. So if you simplify this, you will get V3 of 1 as 0.98 at an angle of minus 5.96 per unit. This is the answer for voltage at the third bus. So this is voltage at the second bus. Before that, it is required to find the Y bus elements. So this completes the first topic, that is voltage at buses 2 and 3. Next we have to calculate the real and reactive powers at the slack bus. For finding that real and reactive power at the slack bus, so that is real and reactive power at the slack bus are nothing but P1 and Q1. So that is S1 it is required to find. S1 is nothing but complex power available at bus 1. So if you find S1 in rectangular coordinates, the real part will be the real power and the reactive imaginary part will be the reactive power. So this can be calculated like this with voltage and current. See here, this is V1 into I1 conjugate, but V1 value at the slack bus remains same, 1.03 it is given, but only thing we have to find is I1. So I1 is nothing but, I1 is equal to, usually we know that V is equal to I into Z, I divided by Z. So V is equal to I into Y. So if you want, I is equal to V by Y. So current is equal to V divided by Z. So this is V into Y. Use this formula, you will get V1 Y11 plus, if you see this system, first bus it is with 2 transmission lines, we have to consider the current in those 2 lines. So that's why, so y12 V2, y13 V3. Latest calculated values of V2 and V3 we have to use. This is the slack bus voltage is 1.03, it is given. Y11 we know that y11 value we know. So let us substitute y11 value, that is minus j 4.8 plus y12 value is known, j 2.5. V2 value we know, that is 1.09, 2.9. So y13 value is known, 2.5. V3 of 1 is known, that is 0.98 at an angle of minus 5.96. So all these values are known. If you know all those values, you can find the I1 value. So I1 will get 0.4 at an angle of minus 7.3 per unit. Once you know the value of I1, you can find the S1. So S1 is equal to V1 into I1 conjugate. If you do the simplification, you will get this answer as 0.4 plus j 0.05. So the real power is 0.4 per unit and the reactive power is 0.05 per unit. So I hope all of you understood in the calculation of voltage at buses 2 and 3 and the real and reactive powers at the slack bus for a given test system we found. I hope this video will be useful for learning the problems on Gauss Seidel method in load flow analysis. Thank you one and all.